We're now going to determine whether a decimal is a solution of an equation. We're going to do this by plugging in our y values into this equation and figuring out which one is going to be the correct solution, if any. For this first part, A, we say that y is -4. When I substitute -4 for y, I get -4 plus 0.6 equals -3.4. Remember, we're trying to figure out if this is the solution. Because I'm adding a negative with a positive, I'm really going to subtract, and my sign is going to be a negative because the larger number is a negative. Four take away 0.6 is going to be 3.4, or a -3.4. That actually equals -3.4. So y equals -4 is the solution. If we plug in -2.4 plus 0.6, we probably won't get this to match because we've already found our solution. But we're going to go ahead and plug it in anyway and work it through. Again, we're going to be subtracting because we're adding a negative with a positive. And our answer will be negative because 2.4 is larger than 0.6. So a -1.8 is not equal to -3.4. Okay, let's look at the next problem. Here we have m over 1.5 equals 5, or m divided by 1.5 equals 5. We're going to plug in 10. So we've got 10 over 1.5 equals 5. Now what we're doing is we're going to be dividing 10 by 1.5, and we'll see if we get 5. So 10 divided by 1.5, we need to move the decimal place over, so we need to move it over here and add a 0 as a placeholder and bring up our decimal point. Now 15 does not go into 100 evenly. It goes into 90, 6 times. 6 times 15 is 90. And we're going to get 10 remaining. And we could write it as, as 10 fifteenths, or 2/3, 6 2/3, or we can write it as a decimal. It's going to become 6.67. It's a repeating decimal. That is not going to equal 5, so 10 is not the solution. Now let's try 7.5, or 7 5/10. So 7.5 over 1.5, does that equal 5? I'm going to divide 7.5 by 1.5. I need to move the decimal place over. 15 does go into 75 exactly 5 times. So m equals 7.5 is the solution.